Welcome back to the deep dive. Today we're jumping into something that's, well, it's a bit of a paradox, actually.
It really is.
We're looking at this piece of high-end, long-haul fiber optic technology, but it's designed for the most basic, oldest video format you can think of.
We're talking about standard analog video, CVBS.
Right. Specifically, the Thor broadcast F-8V-TxRx. It's an 8-channel composite video over fiber unit. So the big question for this deep dive is, why? Why are we sending 1980s-style video signals potentially 120 kilometers?
And that is the core mission, isn't it? This technology exists as this crucial bridge. It's a specialized solution for modernizing the range of a system without forcing you into a massive, expensive overhaul of perfectly good analog cameras.
Okay, so let's start there. Why is this old CVBS signal still even relevant? I mean, I'd assume most serious high-end security has moved on to HDSDI or IP streaming by now.
You would think so, but you'd be surprised. Our sources show that a lot of highly dependable camera systems, especially these huge industrial or, say, defense settings, they still rely on that simple composite video output.
So this Thor unit is all about maximizing the investment that's already there.
Exactly. It extends the life of that equipment. And it's not just about the cost. There's a huge reliability factor here.
Oh, really? How so?
Well, the simplicity of a CVBS signal on a dedicated fiber link can actually be more robust, more dependable than trying to manage a complex IP network over those same vast distances.
That's interesting. And it's versatile, too. It handles what? NTSC, PAL, CCAM.
It handles everything. Any analog format, it truly doesn't care. Which, of course, brings up the question of quality, right?
Yeah, exactly. How do you keep an analog signal from getting noisy over that kind of distance?
That's where the engineering really shines. Even though the input is analog, the unit uses high-end 10-bit digital video encoding internally.
10-bit? Wait a second.
Yes, and that is not a cheap component. It's the very same quality of encoding you'd find in Thor's much more expensive dedicated broadcast transmitters.
So you're saying this isn't some stripped-down budget version for security installs. It's got broadcast-level guts inside a less expensive chassis.
That's it, exactly. You get serious quality protection for that old signal.
And it's efficient, too. It handles 8 separate video inputs.
8 independent CVBS inputs, yeah, all on standard BNC connectors.
And sends all 8 of them down a single optical fiber.
A single fiber. It's just smart bandwidth optimization, you know, perfect for areas with dense clusters of surveillance points.
Okay, let's talk about the range, because this is where the value proposition just becomes undeniable.
This is the key feature.
The standard unit, just using single-mode optics, already pushes that analog video up to 20 kilometers. That's over 12 miles.
Already very impressive. But the optional extended range is where it gets astonishing.
Right.
With the right optics, this system can push that same baseband CVBS video up to 120 kilometers.
120 kilometers. It's hard to even visualize that scale. That's like sending a live video feed across half the distance between New York and Philadelphia.
On an analog signal. It fundamentally reframes what we think of as a legacy system.
It really does. But let's challenge the cost on that for a second. Is it really the low-cost solution when you factor in the single-mode fiber you'd need for 120 kilometers?
That's a critical question. It's cost-effective if that fiber is already in the ground.
Or if the alternative is replacing hundreds of existing cameras with new HD systems.
Exactly. This saves the cost of all the endpoints. And to make that system truly complete, the unit can be optioned to carry a lot more than just the video.
For a huge security system, you need more than just images. You need control.
Precisely. The system can be optioned, it is model dependent, mind you, to also carry data. It supports common interfaces like RS-232, 485, 422 for camera control.
And what about audio?
It sends high-quality audio right alongside those 8 video streams using 24-bit quantization. All of it, the video, the audio, the control signals, across that same incredible distance.
So when we boil it all down, what does this mean for you, the listener? This technology allows legacy analog signals to perform like modern long-haul data. It offers a high-quality, cost-effective alternative to jumping straight to HDSDI.
It's the ultimate infrastructure preservative.
I like that.
And this raises one final thought for you to consider. Given that extreme range capability, up to 120 kilometer, what unique, massive-scale infrastructure projects are out there right now?
Things like cross-country pipeline monitoring or border surveillance.
Exactly. Or vast open-pit mine security. Think about the projects that are relying on the dependable simplicity of 8-channel analog CVBS simply because this kind of range extension is now possible.
What essential, simple information is being secured across those tens of miles? Something to think about.